All right, people, here we are, section 9.1b, 9.1b, graphing quadratic equations. So the first section we talked about all the different things that you can do with these quadratics and kind of analyzing them. Now we're actually going to go on to the graphing part, which includes some of the analysis that we did in 9.1a. All right, so we know we've got y equals ax squared plus bx plus c. That's our form of the equation. So how do you graph one? Okay, so the first step we're going to do is we're going to put the vertical axis of symmetry on the graph. Okay, so we know that that is our x equals negative b over 2a. And when we do that, let's make it a dotted line so that we can graph things over it. It's just going to be the axis of symmetry is going to be dotted. Then we're going to plot the vertex. And remember, this is the point xy that's on the axis of symmetry. So you're going to take this x value by using negative b over 2a, and then you're going to plug that into this equation, into these x's, to get your y value. And it's an xy point there for your vertex. The third thing that we're going to do is we're going to plot the y-intercept. Remember, that's always your c value, so it's easy to do. And then when we plot that, we can use the axis of symmetry for a mirror point. So we know that they're going to look like a mirror image on one side or the other, so you can use the axis of symmetry and get a mirror image point from your y-intercept. Okay? And then the last thing is we're going to put the solution. So we're going to solve it, factor it if you can, and there's other ways to solve, and we're going to solve it, and then we're going to put those solutions on the x-axis. And those actually become the x-intercepts. Move this up a little bit. So those become your x-intercepts where it crosses the x-axis. Okay? And the last step is then we may have to find additional points by using an xy values table if you don't have at least 3 points. Now you might have some points from steps 1 through 4. You might have more points. But if you don't, we're going to use an xy table. Okay? So let's get to it. First one, y equals x squared minus 2x minus 3. Okay? So to find the axis of symmetry first, we're going to look at negative b over 2a. That's our axis of symmetry. So in this case, we've got our a value is, our b value is negative 2. So the opposite of 2 would be a positive 2, right? Over 2a. And our a value is 1, so 2 times 1. So that's going to be 2 over 2, which equals 1. So our axis of symmetry is 1. And remember, it's x equals 1. So that's going to be our graph for the axis of symmetry is. So if I look at that, I've got x equals 1 here, and I'm going to put a dotted line horizontally, vertically through 1 on the x-axis. Okay? Next thing is our vertex. So our vertex, we know, is our x-coordinate, and we need a y-coordinate. So I'm going to use this x equals 1. I'm going to plug my 1 in here and here to get my y-coordinate. So it's going to be 1 squared minus 2 times 1 minus 3. And so altogether, that's going to give me, for y, 1 squared is 1, minus 2 is a negative 2, minus 3 is a negative 4. So that means my vertex, my x was 1, and my y value is negative 4. Because remember, this is y equals this stuff. Okay? Is it a maximum or a minimum? We can tell right away it's a minimum because our a value is positive, which means the graph's going to open upward. And so I'm going to go ahead and graph that at 1, negative 4. So 1 on x, down 4 on y. So there it is. Our y-intercept, we know that is negative 3 because that's always the c value here. So we know that's negative 3. And so I can plot that point as well on my y-intercept down at negative 3. Okay? Now remember I said use a mirror image point. So I can use the axis of symmetry. So, well, it's 1 to the left, so there has to be a point 1 to the right as well. So there would be an easy image point. And you can factor it and find solutions. I'm going to save that work for you. If this one does factor, it comes out to 3, negative 1. And so those are our solutions. Those become your x-intercepts. So every time we were factoring, there was a reason why we were doing it, because now when we graph it, those are our solutions at 3 and -1. So I can put a point there at where it crosses the x-axis at 3. 1, 2, 3, right here, and also at -1 here. So now I have enough points in which I can graph this thing. Okay, I know again this is my vertex, and it's a minimum value. And so now I can connect these dots kind of like so. Just going up this way, and then like that. And try to keep it as symmetric as possible according to our axis of symmetry. So that's one way to graph that one. Let's look at the second practice problem. Okay, -2x squared plus 2x plus 4. So again, looking at my axis of symmetry, -b over 2a, so it would be a, so that would equal a -2 over 2 times -2, which then is going to be -2 over -4, which equals 1/2. So x equals 1/2. So that's my axis of symmetry. So I go here now. I'm going to kind of just go between 0 and 1 the best I can. I know in my graph it's going to be a little bit different, but it should be at 1/2, not quite at 1. Okay. And my vertex, now I know that's my vertex point. My x coordinate is 1/2. So now I have to do a little bit of work as far as my y value. So if I go ahead and plug in 1/2 in here and in here, I end up getting something like -2 times, what does it come out to, 1/4? And 1/2 squared is 1/4. And then plus 2 times 1/2 plus 4. So 2 times 1/4 is going to be 1/2. And then I've got 2 times 1/2, which is going to be 1/4, plus 4. So I'll save some of that fraction work for you and tell you that it's going to be 4.5. Now I know that it's a maximum value here because my vertex is at 1/2. I'm going to go graph that now. 1/2 on x and up 4.5. 1, 2, 3, 4. And a little bit more than that to give it 1/2. So that's my vertex. And I know that's a maximum value because the a value is negative. So it means we're going to open downward here. The y-intercept is our c value, so I know that is 4. So I can graph that part as well, where it crosses the y-axis at 4. 1, 2, 3, 4. There we go. And I'm going to just put a point, over here because I make a mirror image point. And then if you factored this one again, I'm going to speed through that so you don't have to do it. But if we factored this, we could factor it and get a solution of 2, -1. Those would be our solutions. So therefore, I can put those again. Those are my x-intercepts. So where it crosses the x-axis. So it crosses at 2, 1, 2. It also crosses over here at -1. So now I've got enough points to draw this graph as well. This one opens downward, goes through those points. And there we go. Simple as that. Okay. All right. Now let's try one more here. And this one's just a different situation because, well, I'll just show you as we go. Axis of symmetry. Well, it's -b over 2a. And there is no b value. And, so that's 0. 0 over anything is 0. So our axis of symmetry is going to be x equals 0. Our vertex here, when we plug that in here, 0. 0 squared is 0. So our vertex is going to be 0, 0. Is it a maximum or minimum? In this case, it's a minimum because we know our a value is a +1. So we know it's going to open upward. And then the y-intercept, we also don't have a y-intercept. That's going to be equal to 0 because there's no c value. So it's 0. So let's go through it and kind of graph all these things that we know already. So the axis symmetry was x equals 0. So that's right on the y-axis, basically. Our vertex is 0, 0. And we talked about that being a minimum because we're going to open upward. And our y-intercept is 0, so we already got that point there. So now we got to, if we factored this, we factored that we'd get solutions that would be 0. And so we already have a point there. That's not going to help us. So this is one of those situations where we actually have to do an XY table. And we talked about using our common numbers, -2, -1, 0, 1, and 2. And then we're basically taking that function, y equals x squared. And we're going to say, we're going to plug those numbers in and see what we get. So when we do this, we're going to get -2 squared, which comes out to a positive 4. If we do a -1 squared, that's going to be a positive 1. 0 squared, we don't really have to do. We know it's 0, 0. We know that point already exists because that's our vertex, 0, 0. And then 1, we know that 1 squared is equal to 1. And then 2 squared is equal to 4. And you can kind of see just by our table that you're going to have some symmetry. These values are the same, 1 and 1. These values are the same, 4 and 4. So you can see on each side of the x-axis already just on the table that you're getting some values that are the same. So now we can plot those points. So we plot, say, -2, 4, backwards 2 on x, 1, 2, 3, 4. -1, positive 1. 0, 0 we already had. 1, 1, and then 2, positive 4. And so we can graph this one with enough points now to do this. Okay? So what that looks like now is that's our graph for y equals x squared. And again, that was a little tricky. We had to use the xy table because we didn't have enough points based on other information. And one thing I just want to kind of point out here is that this is called the parent graph, because that's the most basic of these functions is y equals x squared. And we kind of can use this later on to see that's our basic, there's the most basic one, y equals x squared. So we can kind of use it to say, what happens if we change certain things? What happens when you change the a value? What happens in the change of the b value? And of course, the c value we know is the y-intercept where it crosses the y-axis. So what happens when we change all those things we can kind of look at. Okay? Example 4, and we're going to skip example 4 and 5 because actually number 5 is going to be our practice problem. So this one, the first lesson summary, what do you think is the trickiest part of graphing quadratics? Is it getting the points? Is it the axis of symmetry? Is it the vertex? What do we do there? What's the easiest part? And then your practice problem is going to be number 5. Graph this equation, y equals x squared plus 4x plus 3. Just do number 5 on your notes, because then you can fill out all that other stuff. The axis of symmetry, the vertex, the y-intercept, is it a maximum or minimum, and factor it to get other solutions. Okay, so that is it for section 9.1b. We will see you tomorrow with your questions.